We've done all these different types before getting to 5, 6 here on factoring, square roots, squaring both sides, and all these different forms that we've done. We've done vertex form, standard form, intercept form. Now what do we do if we've gone through all that and we're still having issues with some things? Well, this is kind of our, I like to call the quadratic formula the duct tape of math. It can be used for everything, okay? Whether it's a slide and divide problem, it's short. As long as it's quadratic, I can use the quadratic formula for it. But sometimes having a graph can be nice. To figure out how many solutions there are to something, all I'm going to do, if I have a picture, is to find the solutions, I'm going to look at the x-intercepts. However many times my graph crosses the x-axis is going to be the number of solutions I would have. It doesn't tell me the solutions exactly, but it tells me how many there's supposed to be. So for number 1, for example, how many times does that graph cross the x-axis? 2. Right here, right here. So I have 2 solutions. Now again, it doesn't tell me what they are. We're going to use something else for that. But I can visually look at that and see. What about the second one? 1. You're like, I thought you always said there's 2 answers. There are, but sometimes depending on what your quadratic is, if you get a perfect square trinomial, which if I factored it would look like this. If I get the same set of parentheses, when I factor it, I'm only going to get 1 answer. What about that last one? Okay, 2. Now there's actually a way that you can end up with 0. Like what? Yeah. You may have a graph sometime. Maybe it goes like this, and it doesn't even cross the x-axis. Well, what does that mean? Does it mean it's not factorable? No. What it means is you're going to get i's in your answers. We're going to find that on a few of these today. So we can't get on a calculator. It's not visual, it's imaginary. But it means you're going to have imaginary answers. So it just means I would be involved in that particular solution set. But we're going to stick with ones that are real here. So the quadratic formula, try to keep this on the screen here. This big ugly looking thing combines 2 things. You should recognize the part that's not underneath the radical. If we remember back to the old x equals negative b over 2a, that's how we used to find, or still could find, the vertex of our parabola. The part that's underneath the radical is what's called the discriminant. And we're not going to use it. Yeah. Here is, we're going to use this formula to actually figure out solutions for these, especially ones that aren't factorable. So, before I can do it though, I always have to make sure that my expression's in standard form. The x squared first, then the x term, then the constant. If it is, great. We write down the values and we jump right in. If not, we may have to do a little bit of adjusting. So for instance, in our first one here, all my terms are on the x squared side, and I see the equal 0, so we're in good shape. My a value is just the number in front of x squared. My b value is the number in front of x. And my c value is the number that's sitting on the end, my constant term. Once I get there, now it's just plugging it in and grinding it out. So I'm going to have negative b, so it's always the opposite of what your b value is, plus or minus square root of b squared nope, the quadratic formula needs to get drilled in. Well, I think, if I'm remembering back, I think as far as formulas go, that this may be the only one we have right now in this section. But it's like anything else. The more you use it, the easier it gets to be and the more you get used to it. So if, when we get done with these, as soon as you keep waiting on the homework, it's going to disappear. It's not a surprise. But the one thing I will mention when you're doing this, even if you're plugging it in, or especially if you're plugging it into a calculator, make sure that b squared term has parentheses around it. Because if it's a negative and you don't put parentheses around it, you're going to get a different value. You're not going to get the right answer. So what I always suggest doing, and yes, it takes a little more time, but I suggest either manually or with the calculator, but not with this radical part, cranking this part out. So like for instance, okay, 1 squared is 1. I can handle that. Negative 4 times 2 is negative 8. And negative 8 times negative 5 is 40. So this is 1 plus 40. I didn't need to make my line quite so long here. So when I simplify this, there's a couple of things I have to look at. The first one is we are not going to decimals on these. The only time we're going to use decimals is when we're doing story problems and it's an application where we're talking about seconds or something like that. Otherwise, my only job at this point is to look and say, okay, can I break this radical down? If I can, I need to. If I can't, I just circle it and I'm done. So in this case, I can't simplify the square root of 41. So I'm just done. And that's how these are going to work. Now, will they always be where I can't break them down? No, of course not. For 13, what's my A, B, and C? 4, 1, and negative 3. So again, I just kind of worked my way through. B minus square root of B squared minus 4AC all over 2, oops, I'm thinking ahead, over 2A, which is 4. And then we're just going to take care of this part, and then we're going to take the square root of whatever that is. And again, you could punch this part in a calculator if you wanted to. And I made that too long again. So that's 1. And I look at this like it's a negative 4. So negative 4 and 4 is negative 16. And negative 3 is a positive 48. So this is 1 plus 48. So I'm like, negative 1 plus or minus the square root of 49. What's the square root of 49? 7. So I'm like, okay, negative 1 plus or minus 7 over 4. Before you circle that. Oh, shoot. I go and I think an 8 before, and then I go back. Thank you. Yes, 2 times 4, definitely 8. Definitely not 4. I was going to look at that in a minute and find that out. Get mad. So here, since I don't have any radicals at this point, since I actually can solve this, I'm literally going to break this up into 2 pieces and find the solutions. So my first one would be negative 1 plus 7 divided by 8. My other would be negative 1 minus 7 divided by 8. And I can actually come up with the solutions. Negative 1 plus 7 is 6. 6 over 8 reduced is 3/4. Negative 1 minus 7 is negative 8. Divided by 8 is negative 1. So if it breaks down, we need to make sure that happens, okay, that we can break it down. You're like, oh, you can't do too many more ball things to us here. Oh, sure I can. Okay, let's jump down to 15 for a minute. There's a couple other twists that can get thrown in, and 14 is not one of the twists. So I get to 15, and I go, all right, what do we got going here? Do I have A, B, and C already? 1, 4, negative 14. So we're like, all right, let's see here. Negative B b squared 4ab all over 2a. So let's see. When I clean up what's underneath the radical, that's 16. Negative 4 times 1 is negative 4. Negative 4 times 14 is plus 56. So I'm slowly, just kind of taking my time here, cleaning this up. Oops, as in B2. Then I gotta stop 16 plus 56. I'm just multiplying out what's beneath my radical here to get that 72. But here's one slight change between this one and 12. Can I break down the 72? Yeah. Nice. Okay, 36 and 2. So I want to get the biggest one. So I'm like, okay, so let's see what's going to happen here. So I look, and I'm like, okay. So I have negative 4, plus or minus, 6, square root of 2. So again, 36 is the perfect square. It breaks down. 2 doesn't. So I get to here. And I go, okay, now I got to be done. And I even broke down the radical. This is awesome. One more thing. Once you think you're completely done, if you can look at all three terms, and there's something that's divisible into all of them. Notice I'm not pointing underneath the radical. Just the stuff that's gotten out of radical jail here. Does anything divide into all three of those? 2. My last step is to divide each of those by 2. Negative 2 plus or minus 3 square root of 2. And I can put it over 1 if I want to, but I don't really need to. I can just leave that at this point. So sometimes the radicals are going to break down like they did in 15. Sometimes they're not, like they are in 12. Sometimes they're going to completely break down like they are in 13. And I'll admit it, sometimes these are going to get downright ugly. For instance, 17 is going to get ugly. So we want to take a peek because then we know how to deal with the ugly ones. All right, 17. My A is 7, my B is negative 2, and my C is 25, right? Negative 25 because, remember, all of my terms have to be on the x squared side. We've got to have equals 0 before we can start. So there's one thing we got to be careful of. When I go to start plugging this in the formula, remember, it's negative b. It's the opposite of whatever b is. So in this case, it's going to be positive 2. Minus square root b squared 4a. Because the formula is negative b. And then it's just going to be the opposite. So that double negative turns that positive. So here, all over 2a. Again, simplify what's underneath the radical first. 4, 800, 700, what? And life starts to get interesting. You're like, Harty, seriously, you're not. You're not telling us we got to break down 704. Yes, I am. Even if it's something smaller. Again, it's the perfect squares you want to be trying to divide in right now. And there's several that go in here. So the bigger the better. And I won't even put all the alternate options on here until probably I'll put a little aside in here. So we got to start plugging away here. I'm not going to just hand this one over. we need to find perfect squares, preferably bigger than 4, because you're going to end up having to break it down a couple of times then. Something bigger than 4 is a perfect square that goes in. Okay? 16? Okay, I was going to say. Oh. Okay, we have options. I've been told you can do 64 and 11, or 16 goes in 44 times. Does it matter which one I do? Yes and no. I can get to the answer both ways. If I go to 64 right away, 8 squared is 11. If I go this route, you're like, well, they don't look the same. Quantity-wise, they are. But again, we want the simplest. Look at 44. I think there's kind of an obvious number that the squares is still in there. 4 and 11. Which would be 2 square root of 11, but the 4 is still hanging out. And I can get the same thing whether I use 16 and 44 as my breakdown. I got to break it down twice though then. Or 64 and 11, which gets me to the answer right away. So once I get that situated, again, I'll just kind of jot this down in case some of you happen to peek at this again later and are going, where the heck did you come up with this stuff? Okay. So you get that breakdown done. You're proud of yourself for doing so, and you should be. And then, just like 15, we take that one last peek. Does something divide into all the non-radical values? 2. 2 divided by 2. Need that 1 there. I got to hold the place. 4 square root of 11 over 7. Just be thankful we don't have to try and factor that. Kind of messy. Oh, damn it. Who's my minus? Oh, Harty. Slipping. So happy that I'm doing the breakdown. Forget the plus minus part. That isn't doing any good either. Now, with the quadratic formula, okay, you can get all these things. If you get a negative number, what are you going to pull out first? An I. Okay. Online humor. All right. So that's how basic quadratic formula is going to work. But as you started to notice that we do sometimes in here now, we want to be able to apply this. So we're going to do some application here. When we go to apply this, okay, we were using this formula back a couple of sections ago into those problems that were up into the 70s. This was my height at the end. This was my height at the beginning. Now, we're going to take that same formula and we're going to add a piece. This new piece called initial velocity, if you're going to launch or throw something. So in this case, we're going to use a baton twirler and a geyser. You could use it throwing a baseball or any number of other things. But this part's going to be our initial velocity. When it first gets released or thrown, how fast is it going? So we're going to have to dig some info out here, but this is the formula we're going to be using. And if I would put something like this on a quiz, that formula I would give you. Just not the quadratic one. So, baton twirler tosses a baton into the air. The baton leaves the twirler's hand 6 feet above the ground. Stop. Which one of my variables does that? Okay. That's my initial height, where I'm initially letting go of the baton. So that's my h sub o, because again, my initial height's where I start. So I'm like, okay, I got that part. Let me keep reading. 6 feet above the ground and has an initial velocity of 45 feet per second. Where's the 45 go? Okay, V sub O. V for velocity. The twirler catches the baton when it falls back to a height of 5 feet. Okay, 5 is my H, where my height is going to end up. I'm releasing it 6 feet up, but when I catch it again, it's not hitting the ground. I'm catching it 5 feet above the ground. And I don't know what T is. That's what I'm trying to figure out. How long is the baton in the air? So I'm going to take that equation. I'm going to fill in all the info that I have. Notice when I plug in the 45, there's a T there that's part of that. So don't lose the T. What's that? Partially. The quiz problem is more like using this, like we did in 5-3. But yeah, it was very similar. What's the one thing I have to do before I can solve this? Okay, right. The 5's got to be over here because we need that 0. And aren't we thankful we don't have to factor it, even though we wouldn't be able to anyway? So you're like, okay, so now what? Quadratic formula, because, again, it's our duct tape. Yes. Yeah. I'm giving away too many points today. Alright. So, here we go. Negative b minus square root of, oh boy, big numbers coming, b squared minus 4ac all over 2a. So I'm like, all right, we got working here. Let's see what big ridiculous number we can get. 25 squared is 2025 plus 64 more. So I got the square root 2089. Here, for some of you can take a deep breath. You're like, oh crap, it's not a perfect square. He's going to make us break it down. No. Story problem. It's an application. We don't talk about speeds in square roots. At least nobody that's normal does. So, we're going to go ahead and turn it into its decimal form. And just going to a decimal point is fine. I believe that's going to be 45.7. But once I get that square root, again, I'm going to bust this up into 2 pieces, because one of these answers is going to make sense and one of them not so much. Square root of 2089. So I'm going to add the 45.7 on one of these. And I'm going to subtract it on the other one. Then I'm going to crank this out on the calculator. I'm going to get an answer. Now remember, if you're cranking on the calculator, either hit enter after you do the numerator or put the parentheses in, because otherwise you're going to get an answer that's all messed up. Let's see, I've got a negative 0.02 up top. And it looks like we got a 2.83 at the bottom. So are both of these legit? No. Which one's not? Yeah, negative. We can't have negative time. That doesn't make any sense. So it takes about 2.83 seconds. That's how long the baton's going to be in the air from the time she releases it until the time she touches it back in her hand. 25, we're going to stop ourselves after letter, oops, this is crossed out though, after letter B, because again, the setup is what's important here. And just seeing, ooh, I got different information, but I can still use that formula. So 25. We got this geyser. We got a blast of boiling water up into the air. During the eruption, the height, h, and heat of the water after t seconds being forced out from the ground can be modeled by this. Now you look at this, and you're like, okay, it looks like the one up above. It's got t squared, it's got t, but there's no h0 on the end. What's that h0 going to be if I don't see it? 0. Okay, my initial height is going to start at 0. Water's starting in the ground. That makes sense. Letter A we can answer without doing any math. What's the initial velocity of the boiling water? 70. You're like, how'd you figure that out? If you come back down, my initial velocity is my v sub o, the number in front of t. So I look at this, and I go, oh, the number in front of t is 70. Okay. And it's talking about feet per second, so it's going to go at 70 feet per second. That's my initial velocity. What's the maximum height of the boiling water? Maximum height. Now let's see. These are all quadratics. So if I was sketching a graph of this, and I see my t squared's negative, is my parabola going to open up or down? Okay, I know it's going to open down. And you think about it, if something squirts up in the air like water, it's going to come back down, kind of in a parabola type thing, even if it's really skinny. So to find the maximum height, I can use the vertex. Oh, the vertex. What's the formula for finding the vertex when we're in standard form? Negative b over 2a. So to find this maximum height, I'm going to have to find this x value so I know what y is. So let's see. There's my b. So negative b over 2a. And again, we're talking about reality here. So we're not going to talk in all this fractional mumbo-jumbo. Now that's my x value, but again, the x value just tells me, okay, here's the middle point of my parabola. I want to know the height. Well, height is y. So I got one last step. Y is going to be replaced by like what this h is. So now, when I go through here, written that as my t, my x becomes t in this case. So I've got negative 16. Fill in the value you got from the first part for the squared portion, plus 70 times the value I just found. And again, this is an actual application, so you're going to get answers that are kind of strange looking, possibly. Yeah, the story problems are our application problems. And so we can figure out how high this goes. And that's where I'm going to kind of stop you, because the two story problems that you do have are going to focus in on how 24 and these first two steps in 25 work. Because how long is the water in the air? If you were curious, and I always have a couple people that are, this was my h. So if I wanted to solve this, I would take this equation, I'd get all my terms to one side, and then I'd just do the quadratic formula on it. That's just one of those, if you wanted to see for future reference how this might possibly work, and then I'd do the quadratic on this. But we've done the quadratic so much already, I won't put you through anymore. So here's our deal. Let's switch this up a little. Okay. Homework's down here at the bottom. Again, the application problems are the last two. Otherwise, you're basically just going to be doing the quadratic formula and breaking things down as best as you can. Yep. The homework check goes along with the quiz on Thursday. So it will be the 5-5 homework, this homework, the quiz preview, and that sum of squares sheet, that 8 problems that we had on that other one. So it'll be those 4 will be what you're looking at as far